Good morning, students. Today I will teach limit of the function. Okay, right? Limit of the function. Okay. So all of you know the function. Yes. Function means the relation between two variables. Suppose if we consider two variables x and y, they are so related that one increases the function, the one variable is increased, then other also increase, or one decrease, other also decrease, or other inverse also may be. Suppose y equal to 1 by 2x. Okay. Then here if x increases, then y also decreases like that. That is the relation between them. Okay, and their domain of definition means the set of all real values of x is known as its domain of definition, and the range of the function, the set of all real values of y is called range of the function, etc. etc. Okay. Suppose and we know very well when a function is said to be defined when a real value exists. Okay, the real value exists. Suppose I am writing one function, the real value exists in there. Then it is always defined. If does not exist, then not defined like that. Okay. Acha. See, suppose I am writing one function. Look at here. Suppose I am writing f of x square minus 1 by x minus 1. Now children, look at here. If we put x equal to 1, suppose x equal to 1, f of 1. Now 1 minus 1 by 1 minus 1. So a 0 by 0 formula here. This is undefined, no real value. Okay. Understood? If we put x equal to 1, then it is completely undefined, no real value is there. But if we put, suppose x equal to, suppose 1.01, very close but not equal to 1, look at here, 1.01. Then you will get f of 1.01 equal to 1.01 whole square minus 1 by 1.01 minus 1. So base will be a square minus b square a plus b into a minus b. Okay. So we are getting 2.01. Approximately 2 from this one, 2.01. Say a plus b a minus b, then down will cancel. Okay. Now it will be 2.01. Should be approximately, this is 2. Suppose if we put here x equal to suppose 0.99 put. Okay. Now we are getting f of 0.99 equal to 0.99 whole square minus 1. Okay. By, you have to write 0.99 minus 1. So a plus b minus b is there, 1.99 is there. Okay. So you can let approximate 2. Whatever the value are taking now, 1.01. Okay. 1.01 and suppose 0.99. See, these values not equal to 1. So we have to write this one. X tends to 1. The value x tends to 1. Okay. From right hand side of 1 and also left hand side of 1. Okay. So you have to write x tends to 1, but x not equal to 1. Keep in mind. When you write x equal to suppose 1.01, so right hand side of 1, and when you write 0.99, so left hand side of 1. Okay, both are tends to 1 but not equal to 1. Not equal to both the side, that is left hand side also and right hand side also. Okay, so here x is a variable, 1 is a constant is there. Okay, so if we put here 1.01 or 0.99, okay, the value tends to 1. The given function has getting a one real value exists in a real value. Okay, which is approximately, that is 2.01 approximately 2. Here also 1.99. So it is also approximately it will be 2 approximate 2 is there. Okay. So you have to write here this tends to 1. Okay, x tends to 1 means x not equal to 1. Okay. Now look at here. So this part you can write again say suppose limit, right, limit LT or LIM, anyone equal, right, limit, writing so x tends to 1 f of x. Now write limit x tends to 1 x square minus 1 by x minus 1. Now you apply to limit x tends to 1 x plus 1, we can write x minus 1 by x minus 1. Now look at here. Since x tends to 1, that is why means x not equal to 1, so you can cancel this part. No? Now write. So limit x tends to 1 x plus 1. So expression will be 2 is there. Just the function is not defined. Just you put here x equal to 1. Then 1 plus 1, 2. See, this means, so here no, limit x tends to 1 x plus 1. Okay, so you can write here, suppose not equal to 1, okay. So write limit x tends to suppose 1.01, right. If we put here, okay, suppose we are putting x equal to 1.01. Now look at here. Here this will be 2.01. Approximately 2 is there. And if we put x equal to 0.99, so we get 1 plus 0.99, so equal to 1.99. This also approximately 2 is there. Okay. So since this is not, this is completely defined, so just directly put here x equal to 1, that is limit x tends to 1 x plus 1. You can add 1 plus 1, this is 2. Okay. Similar way, if we write suppose and limit x tends to 2 x plus 2, so write 2 plus 2 equal to 4 is here. Okay. Similar way, wait. Okay, similar process. I am writing as suppose limit x tends to suppose 5 x plus 5. What is the value? 5 plus 5 equal to 10 is there. Suppose limit x tends to 2 thrice x plus 2. So write 3 into 2 plus 2, that is 8 is there. Limit x tends to suppose 4 x square minus 4. Okay, so you can write 16 minus 4 equal to 12 is there. So here look at it, the function is completely defined is there at the point x equal to 5. Suppose if we write, suppose limit x tends to 2, 2 minus x. See, this is not defined is there. Because if you put, suppose x equal to, right, 2.01, right, the final this value will be 2 minus x. So you can write 2 minus 2.01. So minus root under 0.01. Root under negative. So a limit does not exist in 2 plus. Okay, 2 minus it is okay, but if we take 2 plus, this function is not defined. So limit does not exist. But look at here, either lower limit or upper limit you put, you will get the result, no problem. These all are defined values there. This is the things. So we can write here the function of a limit. Okay, limit, we have denoted the symbol. So in general form, write limit x tends to a f of x. This symbol we have to write here. Limit x tends to a f of x. Okay, so writing here, wait. Okay, so limit x tends to a f of x. So here, so R H L, write the limit first. Okay. So limit x tends to a plus f of x and LHL, limit x tends to a minus f of x. Left hand limit and right hand limit. Left hand limit, right hand limit. Okay. So if both belongs to real number, exist real number, and both are equal, then we can say original given of the function limit this one, this limit x tends to a f of x exists when a limit exists, when left hand limit and both right hand limit both are real number exist, okay, real value exist and both are equal, then we can say the limit of the function exists, otherwise not exist. I'm just not giving the example, that is example I'm giving. Okay. Suppose limit x tends to 0, 1 by x. Okay. Undefined. So if you look at here, if we write here this part, LHL, so it will be plus here x tends to 0 minus 1 by x. So it will be minus infinity. Okay. And RHL will be limit x tends to 0 plus 1 by x will be plus infinity. Keep in mind. Okay, so here limit does not exist. You can verify it also. The number, suppose x equal to 0.1, 0.01, 0.0001 is like that. You can give the example. Okay, you have to verify it. Okay. So limit x tends to a f of x represents the limiting value of a function. Okay, it exists or may not exist. If both the limit, right hand limit and left hand limit both exist, having real value, then we can say original limit of the function exists. Okay. Here a minus a plus, keep in mind. Okay. That is a plus, so a is constant, x is variable, okay, various type of marks. So from left hand side tends to a right hand side tends to a. Okay. Achha. Now I am showing say, suppose limit x tends to a f of x and f of a function value. This is the limiting value of a function, but this will be functional value. Okay. Suppose I am writing here limit f of x equal to, suppose, x plus a. So you put f of x equal to a, then you will get a plus a. So this is twice a. You are getting the value. But here limiting value of the function. Okay. It maybe exist or does not exist. So right hand limit exists, both are equal, and left hand limit also equal, both are value are equal. Then you can say this value exists. Okay. And if we consider the function, look at here. Suppose limit x tends, suppose writing f of x equal to x square minus a square by x minus a. Functional value, look at, if we put a, x equal to a, so this is 0 by 0 form. But here limiting value exists is there. See now, limit x tends to f of x, you put here, you will get twice a. Understood? So this is the difference between, suppose limit x tends to f of x, here x tends to f of x and f of a of the function. Okay, few formulas are there, you have to remember. Okay, wait, one by one discussing. Now right, suppose limit x tends to a x to the power n minus a to the power n by x minus a. So it will be n a to the power n minus 1. n a to the power n minus 1. Limit x tends to a x to the power n minus a to the power n by x minus a n a to the power n minus 1. N belongs to any rational number. Okay, take a rational number. Suppose I am writing limit, suppose x tends to suppose a x to the power 3 by 2 minus a to the power 3 by 2 by x minus a. Okay, so you can write here just according direct formula you can put here 3 by 2 a 3 by 2 minus 1, that is 3 by 2 a half. Okay, suppose writing limit x tends to a suppose 2 x to the power 4 by 3 by minus 2 to the power 4 by 3 by x minus 2. Just you put here 4 by 3 to 4 by 3 minus 1. So 4 by 3 of 2, that is 1/3. We can write 2 square, no, so 2 square is 7 by 3 by 3. This is the answer is there. Okay, suppose writing here limit, see x tends to suppose 3x cube minus a cube by x minus a. Okay, now you can do this in both the process you can do. Suppose you can do factorize, then you can also the value of the limit, and if you direct value you can put according to this formula, you also get the value. Okay, see here factorize is possible, that's why I'm writing here. Sorry, right, not 3, right? So this is a, right? Okay, so write x minus a into x square plus ax plus a square by x minus a. Okay, so limit x tends to a. So both x minus a cancel, x minus a cancel. Okay, now we can write here put the value a square plus a square plus a square. So we are getting 3a square. Okay, note it down. Okay, so formula, all of you remember this type formula. Okay, now okay, again right, limit x tends to 0 e to the power x minus 1 by x equal to 1. Limit x tends to 0 log of 1 plus x by x, always 1, keep in mind the formula. Limit x tends to 0 e to the power x minus 1 by x is 1. Limit x tends to 0 log 1 plus x by x is always equal to 1. Now right, suppose I am writing a limit x tends to 0 e to the power 3x minus 1 by, suppose x is there. How to solve? See here x, here also x, keep in mind. Okay, so this one you can write limit x tends to 0 e to the power 3x minus 1 by 3x, right, into you can write 3 now. So this value is 1, this will get 1, so 1 into 3, right, 3. Again, suppose limit x tends to 0 e to the power 4x minus 1 by suppose 5x. So right, limit x tends to 0 e to the power 4x minus 1 by right 4x into you can write 4 by 5. See, both are same now. So right, so this value is 1, this is 1. So right, 1 into 4 by 5, that is 4 by 5. Okay. Suppose I am writing, say, limit x tends to 0 e to the power alpha x plus e to the power beta x minus 2 by x, right? Okay. So right here, we can write limit x tends to 0 e to the power alpha x minus 1 plus e to the power beta x minus 1 by x, right? Okay. Now limit x tends to 0 e to the power alpha x minus 1 by x plus limit x tends to 0 e to the power beta x minus 1 by x also. Now write limit x tends to 0 e to the power alpha x minus 1 by alpha x into alpha, you can write now, plus limit x tends to 0 e to the power beta x minus 1 by beta x into beta. So right, this is 1, this value is 1, so alpha plus beta. Alpha plus beta. Okay? Okay. Again, suppose limit x tends to 0 e to the power x plus e to the power minus x minus 2 by suppose x. Okay, say you can write here limit x tends to 0 e to the power x plus e to the minus x. Okay, say we have minus 1 plus e to the minus x minus 1, you can write also no, by x. Okay, so limit x tends to 0 e to the power x minus 1 by x plus limit x tends to 0 minus x minus 1 by x, you can write. So this value is 1 no, plus we can write limit x tends to 0 e to the minus x minus 1 by right minus x, okay, into you can minus 1. So this value is 1, so 1 here minus 1 into 0 and 6. Okay. Okay. Again next again suppose this part limit, see, suppose limit x tends to 0 here and log 1 plus 2x by suppose 3x. So you can write limit x tends to 0 log of 1 plus 2x by 2x into 2 by 3. Okay, whatever x is there just write down is here. So this value is 1, so you can write 1 into 2 by 3, that is 2 by 3 answer. Okay, again see, suppose the limit x tends to 0, okay, so x tends to e log x minus 1 by x minus e. Okay, so you can write here limit x tends to e log x, you can write log e minus 1 no, log e 1, so x minus e. Okay, let x minus e constant, suppose h, x tends to e, then you can write h tends to 0. If you put x minus equal to h, if x equal tends to e, then you can write h tends to 0. Okay, Now write limit h tends to 0 log x, we write e plus h, no, minus log e by h. Now write limit h tends to 0 log of e plus h by e, you can write, no, h you can write e into h by e. Take e common outside, take 1 by e, limit h tends to 0 log 1 plus h by e by h by e. So this is 1, so 1 by e into 1, that is 1 by e answer. Whatever discussed now today, okay, I am discussing here now. All of you do at home. I will give the study material also, and also worksheet. All of you solve at home, okay, and all of you send me the worksheet, solution set of the worksheet, okay, because here assessment marks is there. If you do not submit assessment, okay, then you will lose the marks, you will not get the marks, keep in mind. Okay, bye.